Morning, dear students. Today we'll discuss about problem on hydrothermal scheduling for short-term coordination. So this is the problem. So a two-plant system having a steam plant near the load center and a hydro plant at a remote location is as shown in figure. The load is 500 megawatts for 16 hours a day and 350 megawatts for 18 hours a day. The characteristics of units are C1 equal to 120 plus 45 PGT plus 0.075 PGT square. Omega 2 equal to 0.6 PGH plus 0.00283 PGH square in meter cube per second. So here we need to find out the generation schedule, daily water used by the hydro plant, and daily operating cost of the thermal plant. So where gamma j equal to 85.5 rupees per meter cube hour. So this is the uh, diagram. So here the two plants are there. So here the thermal plant is connected nearer to the load center. So that's why here the transmission loss of the thermal power plant is 0, and also penalty factor for thermal power plant is 1. So next, coming to solution, first you write the C1 equation. So C1 equal to 120 plus 45 PGT plus 0.075 PGT square. So here this is the coordination equation for thermal power plant. So it is dou C1 by dou PGT equal to 45 plus 0.15 PGT. So in terms of rupees per megawatt hour. For the hydro plant, the coordination equation is given by gamma j into dou omega j by dou pgh into 1 by 1 minus dou pl by dou pgh equal to lambda. So here we know the value of omega j equation and gamma j. So we need to substitute all the values. So then we will get this equation. So here this is the penalty factor equation, that is LT equal to 1 by 1 minus dou PL by dou PGH equal to 1. Here we need to find out the PL value, that is transmission loss value. So PL equal to BT to PGH square, that equal to 0.001 PGH square. So here we need to substitute this value in this equation. So we will get so 1 by 1 minus 0.002 PGH. So in this equation, so that is related to hydroelectric power plant. So here, so we have two cases. In the first case, when PD equal to 500 megawatts means when the total demand equal to 500 megawatts, how the two plants will be distributed the total demand. So here, first we need to consider that coordination equation and demand equation. So by considering these two, so we need to write the equation in terms of PGH and PGT. So this is the equation number 1, and so here the total demand, in terms of total demand, we have the equation is PGT plus PGH equal to PD plus PL, where PD is 500 megawatts. So PL is 0.001 PGH square. So by solving these two equations, so we will get the PGH value equal to 81.876 megawatts. So if we substitute this PGH value in equation number 2, we will get PGT equal to 424.8 megawatts. Transmission loss equal to 6.703 megawatts. Coming to case 2, here also the demand is different, that PD equal to 350 megawatts. So here we need to rewrite the equation number 2 in terms of 350 megawatts. Then we will get PGT equal to 350 plus 0.001 PGH square minus PGH. So substitute equation 3 in equation 1. So we will get this equation. So by solving the above equation, we will get the PGH value equal to 58.5851 megawatts. By substituting the PGH value in equation number 3, we will get PGT equal to 294.847 megawatts, PL equal to 3.43 megawatts, where PGH is nothing but the power generation by hydroelectric power plant. PGT is nothing but power generation by thermal power plant. PL is power transmission loss. So daily, so here at last we need to find out the daily water used by the hydro plant, and also we need to find out the total operating cost of the thermal plant. So first we need to find out daily water used by the hydro plant. So omega equal to 0.6 pgh plus 0.00283 pgh square meter cube per second. Here so we have two cases. That's why we need to we will get two terms. The first term is daily water quantity used for a 500 megawatts load for 16 hours plus daily water quantity used for a 350 megawatts load for 8 hours. So we know all the values, we need to substitute all, and we need to multiply that equation with 3600. So why we need to multiply with 3600 means, here this all are in terms of hours, we need to convert the hours into seconds. So then we'll get the 5.214 into 10 power 6 meter cube. So this is the daily water consumed by the hydroelectric power plant. Next, we need to find out daily operating cost of the thermal plant. C1 equal to 120 plus 45 PGT plus 0.075 PGT square. So here also we'll get the two terms. The first term is operating cost of the thermal plant for meeting the 500 megawatts load for 16 hours plus operating cost of the thermal plant for meeting the 350 megawatts load for 8 hours. So here we know the values, and if we substitute, we will get 6,83,589.96 rupees per day. So this is the solution of the given problem. Thank you. Thank you for watching.